In today's video, we are going to explore polymers by examining their structure, the way their atoms are bonded together, how to recognize and draw them, and why they usually exist as solids at room temperature. Polymers are an incredibly large and varied group of substances that are found in a wide range of everyday items. Despite their variety, all polymers have one key feature in common, which is that each polymer molecule is made up of many smaller, repeating units known as monomers. For instance, polypropylene, which is one of the most common plastics used globally, consists of molecules that can be made up of thousands of atoms. However, these massive molecules are built from much smaller monomer units called propene, which has the chemical formula carbon-3 hydrogen 6. When you align several propene monomers, they can continuously bond together in a repeating fashion to form extremely long chains, which we refer to as polymer chains. Being able to recognize whether a particular molecule is a polymer is an important skill, and this involves identifying the repeating monomer unit within the structure. For example, in the case of polypropylene, we can notice a segment that appears repeatedly along the chain. Once this repeating segment has been identified, we can isolate and draw it on its own. In chemical notation, this repeating unit is typically enclosed in curved brackets and a small letter, and is written to the bottom right of the brackets. This letter, N, indicates that the unit repeats many times throughout the polymer. So, if we were describing a polymerization reaction where 400 molecules of propene combine to form a polymer, we would not draw out the entire polymer, as that would be very time-consuming. Instead, we draw just the repeating unit and label it with the number 400. More commonly, however, we just use the letter and to keep the representation general. It is also important to note that when drawing these repeating units, the chemical bonds that go through the sides of the brackets must be shown to indicate that the chain continues on either side. Now, let's discuss the melting and boiling points of polymers. The atoms within a polymer are connected by strong covalent bonds, and breaking these bonds would require very high temperatures. However, in reality, when we melt or boil polymers, we are not breaking the covalent bonds inside each chain. Instead, we are overcoming the intermolecular forces that exist between separate polymer chains. These forces are much weaker than covalent or ionic bonds, but since polymer chains are very long and have a large surface area, there are a great many of these weak forces between molecules. Because of the high number of intermolecular interactions, breaking them collectively still requires a significant amount of energy. This is why polymers, even though they don't require the extreme heat needed to break covalent bonds, still tend to have relatively high melting and boiling points. They do not melt as easily as simple molecular substances like oxygen or chlorine, which only have a few weak intermolecular forces. However, they do melt more easily than giant covalent structures like diamond or giant ionic compounds like sodium chloride. This is exactly why most polymers remain solid at room temperature. They have enough intermolecular bonding to maintain a stable, solid form under normal conditions. As we mentioned earlier, there are numerous types of polymers, each with unique structures and properties. Two of the most common categories are addition polymers and condensation polymers, each formed through a different type of chemical reaction. We will be covering those types in more detail in future videos. That wraps up today's overview of polymers. We hope you found it helpful, and if you did, feel free to share it with your friends or classmates. We'll see you again next time.